Okay, so this is going to be an introduction to radicals. So radicals being something written with that funny looking sign like this. So that's a radical. That could be a radical. This could be a radical. This is a radical. You could have this whole thing as a radical. Those are all examples of radicals. Ones that people should be familiar with are like square roots and cube roots. So square root is something like this, but if it's a 2, we don't write the 2. We just assume that's the 2. So that's a square root. And then the cube root would be something like this with the 3. It's really, really handy to know your perfect squares and perfect cubes. So perfect squares, they're things like 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. We can write this a little bit faster by going 4 squared is 16, 5 squared is 25, and we can keep going. So I'm just going to do a bunch here. 7 squared, 49, squared, 64. And I'll probably go up to, I'm going to go up to 12 squared. 144. Okay, so those, it's really, really good if you can instantly see 49 is being a square root, 7 squared, or 9 squared is 81. If you can immediately recognize those, it's really helpful. There's also perfect cubes. So 1 times 1 times 1, 1. 2 cubed is 8. 3 cubed is 27. 4 cubed, 64. 5 cubed, 125. I think 6 cubed is 169. And after that, I start getting not so good at it. But if you can know those ones, that's great. A couple of other things to kind of introduce radicals is the idea of, what is a radical? How does it compare to exponent? So we can think of like square root of 9 as being the same as square root of 3 times 3, which we can also think of as being the square root of 3 times the square root of 3, which is 3. So those are that's one way to kind of think of radicals and integers. We can also think of it as square root of 9 is equal to the square root of 3 squared, and that equals 3 as well. Another way to think of what a square root is it's the thing that undoes a square. So if we have 5 squared is equal to 25, and then to undo it, just a little phrase I'm using, to undo the 25, we can go the square root of 25 is 5. So it's like the reverse of a square. So that's another way to think of it. And I think that's kind of it for introduction to, and so that's perfect square, or square roots and cube roots, but we can have higher order roots as well. So we can have like 4 to the power of something like that. We could also have something like, let's see here, 2 times 2 times 2 times 2, that's equal to 16. If we had the 4th root of 16, that's the same as 4th root of 4 to the power 4, which is equal to 4. Or another way of thinking of that would be like that. And that is equal to 4. So there's your introduction to radicals.